Welcome to the DIY Honda Garage channel. In this presentation, we will address the diagnostic trouble code DTC P2127, which indicates that there is a low voltage signal issue specifically in the APP accelerator pedal position sensor B circuit. This military transition in the DTC description needs immediate attention, especially in Honda CRVs manufactured between 2011 and 2016. The APP sensor is a critical component for the throttle control, allowing the engine control unit, ECU, to monitor the position of the accelerator pedal. Its accurate operations ensure optimal engine performance and emissions control. A malfunction in this sensor can lead to significant driving issues or, in worse cases, pose a safety risk. Therefore, it's crucial for technicians to comprehend this error code efficiently, to troubleshoot and remediate the problem effectively. The APP sensor B plays an essential role in the vehicle's accelerator system, located near the driver's side pedal assembly. This sensor works in conjunction with the Powertrain Control Module, PCM, to provide real-time feedback on the throttle position, which affects engine performance. When the accelerator is pressed, the APP sensor B transmits a corresponding voltage signal to the PCM. Ideally, this signal should vary depending on the pedal position to ensure smooth vehicle acceleration. If the signal voltage drops below the threshold of 0.2 volts, as indicated for DTC P2127, it suggests an issue within the sensor or wiring. This low voltage condition can disrupt the communication between the APP sensor B and the PCM, leading to performance degradation or vehicle malfunction. When diagnosing DTC P2127, multiple factors may be contributing to the low voltage reading in the APP sensor B circuit. First, faults within the APP sensor itself can cause erratic functionality or complete failure. It's also common to encounter poor electrical connections at the sensor or the PCM, possibly due to corrosion or loose terminals. Additionally, a shorted APS2 wire, which connects the APP sensor to the PCM, may result in abnormal voltage readings. Conversely, an open wire in the APS2 line can prevent signals from reaching the PCM adequately. Finally, potential internal faults within the PCM may also lead to P2127, which can compromise the whole throttle control functionality of the vehicle. Several symptoms may indicate that the vehicle is suffering from DTC P2127. Drivers might notice an unresponsive accelerator pedal, which can lead to unsafe driving conditions. This may occur together with poor engine performance or an overall reduction in throttle control, making acceleration difficult. Another visible sign includes the illumination of the check engine light on the dashboard, alerting the driver to look into the issue. Additionally, some vehicles may exhibit intermittent occurrences of this DTC, where the symptoms may appear sporadically, making diagnosis challenging without proper tools or techniques involved. The first step in troubleshooting DTC P2127 involves problem verification by powering on the ignition switch to the on position, or I. Once the ignition is on, use the Honda Diagnostic System, HDS, to check the voltage of APP sensor B. Ideally, while under normal conditions, this voltage should be lower than 0.2 volts. If the voltage conditions match the stated threshold, it confirms that the failure is indeed present, and the technician should proceed to the next troubleshooting step systematically. If the voltage readings do not match the threshold, it indicates an intermittent fault, and attention should be directed towards checking electrical connections or loose terminals at both the APP sensor and the PCM. After confirming the initial voltage reading related to P2127, The next step is to determine the possible failure area, particularly focusing on the VCC5 line and other connections. Start by turning the ignition switch off to the lock position, and then disconnect the APP sensor's 6P connector. Once this is done, turn the ignition switch back to the on position. This allows you to measure the voltage between specific test points. Test point 1, located at APP sensor connector number 1, and test point 2 at APP sensor connector number 2. You should find a voltage measurement close to 5.0 V. If this measurement is present, it indicates that the electrical supply is functioning correctly, and you may proceed to the next troubleshooting phase. Conversely, if this voltage is absent, further investigation into potential issues within the circuit is needed. The third step in our troubleshooting approach involves checking for a shorted wire in the APS2 line. Begin by turning the ignition switch to the lock position as a safety precaution. Next, use the HDS to jump the SCS line, which is crucial for conducting further tests. Afterward, disconnect the PCM connector A with 49 pins to isolate the electrical pathways. With the connectors disconnected, check for continuity between specified test points. APP sensor connector number 3 and body ground. Performing this continuity check confirms whether there's a short in the APS2 wire between the PCM and APP sensor. If yes, this needs to be repaired to restore proper electrical function. Otherwise, it indicates that the wire isn't shorted, allowing you to proceed to the open wire check. In this fourth troubleshooting step, the focus shifts to checking for an open wire in the APS2 line. To achieve this, connect a jumper wire between 2 points. Terminal A at APP sensor 6P connector number 3, and Terminal B, which is connected to body ground. Ensure that the conditions are set correctly with the ignition in the lock position and the APP sensor connector still disconnected to avoid any interference. By checking for continuity between the test points at the PCM connector A and body ground, you can determine whether the APS2 wire is indeed intact. If continuity is confirmed, this indicates that the wire is functioning normally, and you can then advance to the fifth troubleshooting step. If there is no continuity, this signifies an open in the APS2 wire, which must be repaired before proceeding. The fifth step in the troubleshooting process involves verifying the internal circuits of the PCM. Start by reconnecting the PCM connector A, ensuring all pins are firmly seated. Following this, a jumper wire must be connected between APP sensor connector number 1 and number 3, while the ignition switch is turned to the on position. Utilize the HDS once again to check the APP sensor B voltage readings. As in earlier steps, the expected voltage should be less than 0.2 volts. If it meets this criterion, refreshing the PCM software or substituting it with a known good unit should be conducted as protocols suggest. However, if the conditions do not match, a replacement of the APP sensor is warranted, which could resolve the issue and lead to successful repair verification. Troubleshooting Step 6 focuses on addressing potential issues with the VCC5 line. As with previous steps, start by turning the ignition switch to the lock position to ensure safety before working on electrical components. Jump the SCS line with the HDS once again to prepare for the test. Disconnect the PCM connector A, then connect a jumper wire between the APP sensor connector number 1 and body ground. This setup allows you to check for continuity between the VCC5 signal wire located at the PCM connector and body ground. If continuity is confirmed, it suggests the VCC5 wire is intact, prompting the suggestion to update the PCM software if it is not up to date, or substituting a known good PCM as the next course of action. If continuity is absent, this indicates an open in the VCC5 wire that must be repaired before moving on to the final steps of verification. The final repair verification process ensures that all previous steps to rectify DTC P2127 have been properly executed. Start by turning the ignition switch to the lock position to facilitate reconnection of all relevant connectors securely. Once everything is reconnected, power the ignition switch back to the on position while being cautious not to start the engine yet. Utilize the HDS to reset the PCM, ensuring that any previous fault codes are cleared from the system's memory. Following this, conduct the PCM idle learn procedure for optimal performance and to establish a new baseline for the vehicle's engine parameters. Lastly, check for any pending or confirmed DTCs to ascertain if the P2127 still appears. If it does, reassess for poor connections or potential failures in areas previously identified. Preventive maintenance practices play a significant role in minimizing the risk of experiencing DTC P2127 in the future. Regular inspection of the APP sensor is crucial for identifying any potential wear or damage that may later lead to performance issues. Technicians should also periodically check all electrical connections associated with the APP sensor and the PCM for signs of corrosion, oxidation, or loose fittings that can contribute to variable signal issues. Keeping all terminals clean can enhance conductivity and reduce the chance of electrical faults. Furthermore, with technological advancements, it's essential to periodically update the PCM software to ensure it operates with the latest algorithms for better performance. These simple steps can help maintain optimal vehicle functionality and avoid costly repairs. In conclusion, understanding the role and functionality of the APP sensor B is vital when dealing with DTC P2127. Identifying the symptoms associated with this trouble code can help in diagnosing severity and urgency, allowing technicians to address the problem promptly. Following a structured troubleshooting methodology ensures that the most common fault sources are systematically evaluated and ruled out, leading to accurate diagnoses. Properly verifying repairs is essential for confirming that the issue has been resolved before returning the vehicle to the customer. Lastly, adopting preventive measures can prolong vehicle health and performance, mitigating the risks of future DTC encounters. Please like and subscribe to the channel. See you next time.